Okay, today the problem is about stocks and prefix sums. So we have numbers. And this is a stock price at each day. And we also have a strategy. So the strategy is to sell, to buy, and to hold. And also we given number K is a sliding window size. And we have to pick the best sliding window or okay, it's either the best sliding window or no sliding window at all. And this sliding window should gives us the best profit. When we apply sliding window, we do it half, and the first half we making hold values, and the second half we making what is it, buy, I would say. Let's look at the description. So okay, the second half is sell, so it's like this. So actually we gaining money or profit. By looking at this intuitively, we can say that the negative part on the first half should give us the most profitable answer, but we can't be sure. So it is better to check all possible sliding windows. It's not that hard. We already know how to iterate over all sliding windows, and the strategy is to plus values on the right of the sliding window and minus values on the left side of the sliding window. The interesting part for this particular problem is that we have two kinds of sliding windows. The first is the size of K. And the second is size of K divided by 2. And let's call this original, and this is modified. And the profit in this window is original profit, and the profit on this window is like modified profit, and this would be hold and this would be sell. So it is gaining profit of this sliding window, and to find this profit you have to just plus prices at each day, because we are not applying any strategy. And for this window it's more tricky because each day has a strategy. So we doing strategy times price on each day, and when we doing the minus, we also doing like minus strategy times price on that day. So this is how this works, and the difference between two windows is like modified minus original, and this is a gain of our application. And to find the total profit, we are doing the sum of original strategy plus this diff maximum. So we doing this kind of iterating all over all the diffs and computing the maximum value of this. Let's look at the code, and this is my the code that I wrote the first time. It's use n space complexity and n time complexity. I just want to make it very simple and explicit to simplify my thinking. So I do this is prefix sum of originals, and this is a prefix sum of modifiers. And to find the gain of the sliding window, you should subtract the right border minus the left position in this prefix sum. So I then compute the maximum difference and I add it to this original result. So this is how it's accepted. You have to be careful to do this every time. Compute the prefix sum and compute the difference only when it is allowed. So when the I is bigger than the window size. So then I implemented some code modifications. Let's look at another solution. So my final Kotlin version is, let's look at it. So it looks like this. I kind of compressed this entire algorithm, but let's make it step by step. So instead of using arrays, I just use the variables. So you can always compute the prefix of window sum with just a single variable. You don't have to keep all the previous values, you just have to subtract. But be careful with exact pointer that you subtracted, and also be careful that to subtract the prefix sum with strategy, you have to multiply it by strategy. So this is the running sum of sliding window. I also have to keep separate variable for sum, because now my original strategy is just a sliding window sum and not the entire sum. And then I compute the difference the same way as the original implementation. I just use the difference between modified and original Windows sums. So this is how it looks like, and it uses of one space complexity and of n time complexity. And this is compressed version. You can save one variable with just sum of operator. It's just for fun, but in Kotlin it takes 22 milliseconds compared to just 8. And in Rust it doesn't make it worse. It's the same like minified version with zip operator and map and sum, and it is 0 milliseconds. So I would say Rust is a perfectly optimized for this kind of fluid aggregator operations. And the underlying algorithm is the same. I tried to collapse these two variables into one, but it wasn't success for me. Like intuitively, I think this is just one variable, but it can be not the case. Let's look at some other people's solutions. So I didn't find solution from Lee, and all other solutions are pretty big. Okay, I think that's it for today.